of activation energy. On the x-axis its return progress of reaction, while on the y-axis its return potential energy. Now if the potential is higher, that is the substrate goes through the transition state to the product always. Now substrate S and the product, between them it's a transition state. Now this transition state is higher when the activation energy without an enzyme. This state is lower when the activation energy with enzyme. So enzymes, so what it's written that enzymes eventually bring down this energy barrier, which is a transition state, making the transition of substrate to product more ease. Factors affecting enzyme activity includes temperature and pH, whereas enzyme shows its highest activity at a particular temperature and pH for the optimum temperature and optimum pH. See in the diagram slide, effect of change in pH and temperature. On the y-axis is the enzyme activity, on x-axis is the pH or temperature. It represents the optimum temperature and pH that indicates the highest activity of the enzyme. Now another factor that affects the enzyme activity is the concentration of the substrate. And so concentration of substrate and enzyme activity on x-axis its substrate, showing the Km value that denotes the half of the maximum velocity of reaction. So velocity of reaction is on the y-axis. When saturation occurs, that indicates the Vmax, that is the total maximum velocity. There is a competitive inhibitor. Inhibition, it is a process that shuts off enzyme activity by the chemical that is inhibitor. One such example is the inhibition of succinic dehydrogenase biomolecules, which closely resembles the substrate succinic in structure. So inhibition. So in here, succinic dehydrogenase was an enzyme that shuts off its activity by the inhibitor, that is malonate, that closely resembles the substrate succinate in structure.